Hello, good morning once again. We'll be talking about the sample proportions of a particular topic in statistics and dealing with it mostly inferentials. But however, when we talk about sample proportions, we actually mean a part of a particular thing that is dictated or found out by comparison, that as you collected a part of a particular populations by what? By comparative knowledge. Perhaps you want to use it to dictate or find out a particular whole number or a whole part of a thing, and that's why we have what? A sample, a proportion. That's how we have a proportion. But going into it, we'll be taking it as what? A part of what? A thing. That is talking about sample proportion. Let's say we can, and let's say we want to know what all the percentage of people in the populations are left-handed in a particular populations. Okay. So having known about that, if it would be impossible, of course, to measure every single persons in the world, so we can take the sample size of 500 people and create a proportion. All right. In doing that, you find out that in our sample of what? In our sample, 75 people are left-handed. So, on that note, calculating your sample proportion is equal to, given on this formula that you are seeing. And then whenever you are asked to calculate anything that has to do with the sample proportion, this formula is very relevant. So, remember I told you on how to deal with the sample proportions. I told you how to deal with the statistics and even the parameters whenever a question is given to you. So these are the parameters to look into. When you substitute into a value of this formula, this is what you get as. So you get 0.15 as your result when you substitute as your sample proportion, 0.15. Of course, that is your P, right? So you go on. If you talk about the distribution, that will give us the knowledge of distributions of a sample proportions. We can find out that the distributions of a sample proportions, if the sample size is less than 5% of the total population size. If on that note, dealing with the distribution of sample proportion, you have the formula to be n plus, that is sample size into the proportion multiplied by 1 minus proportion. If it's less than, there is always a condition attached. If it's less than or greater than, if it's greater than or equal to what? 10, then the distributions of the sample proportion is approximately normal. That is what we do. And then the standard deviation of a sample distributions is taken, and that is where you get this. So applying this formula is what is apparently going to help you when you are dealing with the standard deviation of a sample distribution. On going further, you'll be able to dictate that at so many things, sample distributions of the is have its own. Now to verify if this is actually okay or not, you will find out that this formula will be justified. Let's see. That is on the distributions. Yes, of course, we know that 500 is less than 5% of the entire world populations. Is the distribution approximately normal? Yes, it is normal because it is what? It is completely less than. All right. So following the formulas, imputing the values we have, you find out that what? 63.75. You will find out that 63.75 is greater than or equal to what? 10. So on that note, all you just need to do is, since it's greater than, you go over to applying the formula of what? Distribution of a sample proportions, and talking about the standard deviation of sampling distributions. When you do that, you will get at exactly what you are seeing on the screen. This is all about what we are talking about. That is for what? Standard deviation of a sampling distributions. And of course, at this point, you get your mean of proportion and then your standard deviation of proportion. Thank you. For completing this. Complete to share